And then, like I said, hopefully my colleague will answer me with confirmation before you guys let out. If not, I can shoot you an email with what he says. We'll start off wrong. Let's do it. All right, so your slopes. M is the letter for slopes in mathematics, so we couldn't use S. S is used for other things in physics, so try not to, use multiple letters for multiple things. So M is the letter that we will use to represent your slope. You can calculate your slope one of two ways. It will be y2 minus y1 over x2 minus x1, or you could use y1 minus y2 over x1 minus x2. Notice that as long as you stay consistent with what you use first. So in other words, if you use y2 on first on top, make sure you use x2 first down bottom. Or if you use y1 first on top, make sure you use x1 first down bottom. You will get the correct slope. Also represents rise over run, which we will use when we get to graphing that relationship. So x1, y1 is the coordinates of your first point, x2, y2 is the coordinates of your second point. Both of those points just represent any 2 points on the line. I probably should have put 2 right here. Any 2 points on the line. We'll calculate the slope for you. As a matter of fact, let me go here real quick. When I do this, does the screen go black on you guys, or can you still see?
You still
You still see it.
Okay, just want to make sure, because I want to pull some problems. See someone chat. Still good. All right, cool. This thing is moving slow. Over here.
Professor, I went back and redid that problem I had. Homework.
All right, how did it work for you?
It turned out all right.
Okay. Cool, cool, cool. All right, so let's say we had the 2 points, -2, -4, and then 3, -5, and they asked us to find the slope. Going back to our relationship, I'm going to do it this way first, then this way second, just to show you that both ways will work as long as you stay consistent in your substitution, we'll be all right. So I'm going to label which one is my 0.1 and which one is 0.2. So we'll do it the first way first. So y2 minus y1 over x2 minus x1. Y2 is negative 5. Y1 is negative 4. Make sure you don't lose a negative. There's a minus sign in the formula, and there's a negative that's sitting in front of your 4. So make sure you don't lose a negative. A lot of people make that mistake. X2 is 3. And then x1 is negative 2.
Can you scroll up? I can't see. No, scroll down, down, down. Right there. Thank you.
Mm-hmm. Negative to a negative turns positive. It's negative 5 plus 4, 3 plus 2. So my slope is negative 1 over 5. Questions on that before I use the same numbers to do it again? All right. So x1 is negative, I said x1, y1 is negative 4, y2 is negative 5, x1 should be negative 2, and then x2 is 3. So once again, we have negative times negative or negative applied to a negative in our numerator. So that'll be a plus 5. So I will end up getting a positive 1 on top. On bottom, I get negative 5. So that's still negative 1/5. And so like I said, as long as you stay consistent in your substitution, then you will get the same slope.
Can I recite something back real quick, Professor?
Sure. Mm-hmm.
Basically, you get 2 points and you plug those numbers into that formula.
Yes. Mm-hmm. All right. So let's do it again, just to make sure we're good. 5, negative 6, and 8, 3. Calling my first point the 5, negative 6. Second point be the 8, 3. So we got y2 minus y1 over x2 minus x1. Y2 is the 3. Y1 is negative 6. X2 is 8. X1 is 5. 3 plus 9. 3 plus 6 on top is 9. 8 minus 5 is 3. My slope is 3. All right. No, I'm not going to have one to do it like that. All right, so for the first two, we have 4 of them. We're looking at the basic behaviors of your slope. When you follow the graph from left to right, it's going up. That means your slope is positive. Following your graph from left to right, if it goes down, your slope is negative. All right, so if you have a horizontal line, your slope is 0. If you have a vertical line, your slope is undefined. All right, any questions? Any questions?
You said M is what? M is if it's horizontal.
No, if you have a horizontal line, M is 0.
M is 0. M is 0.
Yeah. And then if it's a vertical line, M is undefined. And I don't think I mentioned your slope. What it actually is. I think it just got into calculation. Your slope is the numerical value of the incline or the steepness of your ramp, or just like when you talk about the slope of a mountain. Basically, you put a number on it, on how steep it is, or how what direction it's going, whether it's going up or down. That negative or positive matters. And so we just put a numerical value or numerical measurement on the steepness or the incline of your ramp. You know, the slope of a mountain, the slope of a roof, that type of thing. So that's what your slope is. All right, so parallel lines, they never cross or touch. They have the same incline, which means they have the same slope. Perpendicular lines will create a 90-degree angle at its intersection. So that square there lets you know they're supposed to be 90 degrees. And their slopes are negative reciprocals of each other. So let's talk about what that means. All right, don't want to scroll up too fast. Is everybody okay? Okay with that? All right, so now looking at negative reciprocals, first thing we want to look at is just reciprocals themselves. Reciprocals are just flipping the fraction. So if I have 4/5, the reciprocal of 4/5 is 5/4. Reciprocal of negative 10/7 is negative 7/10. Reciprocal of 8 is 1/8 because 8 is 8/1. So if you're just talking about flipping the fraction, that's what your reciprocal is. No calculation, just flipping the fraction. All right, so now negative reciprocals, which is what we want for slopes that are perpendicular or lines that are perpendicular. Negative, another word for negative in mathematics is opposite. So you want to flip your fraction and have the opposite sign. So the negative reciprocal of 4/5 will be negative 5/4. The negative reciprocal of negative 10/7 will be positive 7/10. So you flip the sign and flip the fraction and use the opposite sign. Then the negative reciprocal of 8 will be negative 1/8. All right, questions on what a negative reciprocal is? You flip the fraction and use the opposite sign. Let me ask you guys this. Do you guys hear a whistling noise or anything like that?
Yes.
All right, let me try something. Hold on one second. Can you still hear it now?
No.
No? Okay. Now I'm about to try something else.
I just grown accustomed to
I think most of my classes have then, if that's the case. Now, have you guys looked at the videos? Have you heard the same whistling sound in the videos?
I haven't looked at the videos.
Okay. Because I didn't think I heard anything in the videos, but I meant.
Today is the first time I ever heard it.
Okay. So maybe it's not everybody. Maybe that's why I'm not getting a complaint through everybody. Okay, hold on 1 second.
And nor did I hear it in any of the videos.
Okay, well, good. At least it's not in the videos. Now, can you hear it now?
No.
Maybe it was those headphones that I was using. All right, and maybe that's why it's not in every video because I may have switched them out every now and then. Okay, long as we got it straight. The only reason I asked is I had a class before this one today, and they mentioned it. That was my first time having that class. Okay, cool. All right. But yeah, if y'all ever hear something like that or whatever, let me know. I'll see what I can do to rectify the situation. All right. So okay, so let's do this. This line. Trying to write this in a good way. That says and then. I know it's kind of. Let me see if I just write it big and put it right there. All right, so we want to give the line or give the slope of the line that is parallel to the given slope and then perpendicular to the given slope. So I'm going to use this shorthand terminology, shorthand symbols to represent parallel and perpendicular as we move forward. So our given slope is 3/5. If a line is parallel to a line that has a slope of 3/5, according to what we've already mentioned, if they're parallel lines, they're going to have the same slope. So if I want a line that's parallel to this one with 3/5, that means the slope would have to also be 3/5. Parallel lines have the same slope. Now, if I want a slope or the slope of the line that's perpendicular to 3/5, that would be, remember, it has to be negative reciprocals. That means I would flip the fraction and use the opposite sign. All right, questions on that first example? right, so looking at the next one, if my slope is negative 11 over 9, and I wanted a line that was parallel to it, the slope would be negative 11 over 9. Remember, the slopes will have the same, parallel lines will have the same slope. Perpendicular lines. If I had negative 11 over 9, the slope for my perpendicular line would have to be positive 9 over 11. We'll do one more, but questions? Any questions?
I probably won't have any questions till I get into the homework.
I can understand that. I understand that. Sometimes that happens. Most of the time, that's when it happens, you know. You're giving students a password in Zoom now. I think he just answered me incorrectly. All right, so last one like this before we go to using it to graph. M equal to 1 over 7. Parallel line would actually be the 1 over 7. Perpendicular line, we'll flip that, use opposite signs. So that would be negative 7. Negative 7. All right, so let's see where we want to go now. Let's look at graphing. All right. Oh, hold up, not right. All right, so when you talk about graphing using your slopes, the relationship that we will use is rise over run. Your rise will be up or down, run will be left or right. If you notice when we look at calculating, we had our y values that were on top, x values that were on bottom of the fraction of the slope. So that's why the rise, the up or down, is on top, right or left is on bottom, which is your run. So what dictates whether we go up or down, right or left, will be if we have a positive or negative value. So your positive moves will be up and right. Your negative moves will be down and left. So let's say if you had positive 3/4, both of them are positive, so that means I will go up 3 and right 4. So we have, let's say if we had -5/7. I always say just give the negative to the top. You cannot give the negative to the top and bottom, because now negative over negative is positive. So that negative is not assigned to the top and bottom. You got to give it to either or. And so I would let it be -5 over +7. So that means you would go down 5, right 7. But if you decide to go the other way, you could do +5 or over -7. That means you would do up 5, left 7. So if we look at what's happening here, we would have a point that we would have. And if I go down 5, right 7, it'll put me here. If I go up 5, left 7, it'll put me here and still create that same line. So that's why it still wouldn't matter. You just got to make sure that you only give the negative to either top or bottom, not to both. All right. Questions before we go a step further? So we haven't used it to graph yet. We're still setting up that foundation. All right, one more thing before we go ahead and graph, which is the slope intercept form. All right, so your slope intercept form. We know M represents our slope, but B would represent our y-intercept. So if you have your equation solved for y, your linear equation solved for y, then it is in slope intercept form. And you can use that to graph. I'll go 2/3. So if you have 2/3 x plus 1, your slope is 2/3. Your y-intercept, which is b, would be 1. So if I have y equal to -8/13 x minus 5, slope will be -8/13. Your y-intercept, like I said, that is the letter b that we're referencing in the formula, would be -5. Also take note, because a lot of people make this mistake, when you're talking about your slope does not include x. It's the term or the number that's in front of x. So if they ask you what is your slope, do not put 8x over 13. Do not include the x at all. Up to this point, for your slope, all you saw were numbers, and so that continues on to be the case. Your slope does not include x. Your slope is just a number in front of x. So if you go back to your formula, notice m is sitting in front of x. Let's see, plot. All right, so first thing we have to do whenever you're going to graph using your slopes, you're going to plot the y-intercept first. And then from the y-intercept, you're going to generate another point. So that's key as well. There's a lot of people, they would generate a point with the slope information from the origin. Remember, you will only come from the origin if you have a point. Your slope is not a point, it's directions. Remember, we go up 3, right 4. Those are directions. That's not actually a point. So you're going to generate another point from your y-intercept, not from the origin. So let's see how that will work for us. If we have y equal to, let's go back to 2/3 x. Let's go -1. Y equal to 2/3 x minus 1. Our slope is 2/3. Our y-intercept is -1. So now, 2/3 +2 over +3 means I go up 2, right 3. Now, y-intercept, remember we talked about intercepts last class? The characteristic of all y-intercepts means that x is equal to 0. So that means the coordinates of my y-intercept is going to be 0, -1. So that will always be the case. You will have this number right here, and then the first part of your coordinate will be 0 when you go to plot. So we're going to graph the y-intercept first. So that's 0, -1. Now, from the y-intercept, I'm going to go up 2, right 3. Oh, went too far. And that would be my other point. Questions on that before we do another one? All right. Here, if we have y equals negative 1/4 x plus 3, our equation is in y-intercept form, slope-intercept form. So we can just pick out what our slope would be, which would be negative 1/4, and then the y-intercept is going to be 3. This is negative 1 over positive 4, so we go down 1, right 4, 3 as a y-intercept is 0, 3. Before we graph, questions? All right, so 0, 3 is right here, my y-intercept. Then from my y-intercept, I go down 1, right 4. And that's my line. Questions? Any questions? See, slope, intercept form. Okay, we can do the last 2 sections next class.
Negative 1.
Say that again now.
Go down negative 1.
Well, you go down 1. That negative 1 tells you to go down, and then the positive 4 on bottom tells us to go right 4. All right. So a student does not have to take MDE 61 with 161. You can suggest they take them together if the student's overall grade is below 80% in MDE 60. So that's how that 61, like I thought 61 is a supplement to 161. You don't have to take MDE 61.
All right, cool.
Yep. But like you said, it is suggested if the student's overall grade is below 80% in MDE 60.
So I can just roll right into pre-cal.
Yep. After you get this, A plus, this 101 out of this class, yeah.
Hey, I keep my fingers crossed and pray it up.
So,
Speak it into existence.
yes, sir. Got to speak that positivity. Got to speak life. So if you guys don't have any questions, I will stop here. Next class, we will do the last 2 sections out of chapter 5, and then we'll be looking to prepare for this test. I don't think we talked about how we're gonna do tests in this class, have we?
I think you said, I could be wrong. You said that you monitor the test. Some professors make you use your cell phone.
Yeah, and all the different things. Yeah.
But
So
anything else you talked about?
right. What I may do, we'll talk about it next class. What I may do instead of doing or making everybody take the test on one single day is let you guys test through the center, and that way you can take it on your own time.
What do you mean test through the center? How'd that work?
Well, you would call, not call, you would email Mr. Davis, and he will set you up to, you wouldn't go in. It would be through Zoom, and they would just watch you like I would. But because if I do it, then everybody has to do it on a certain day. If I do it through the center, then everyone could go on their own time. And because everybody might not be in the same place or be ready on the same day. And that would allow you guys the flexibility to take the test at different times.
So we would email.
Yeah. Well, I'll iron out those details and give you all the information, when we're ready. So probably by next class, I iron out the details with Mr. Davis
All
and
right.
see if that's a legit possibility, because that would alleviate some pressure as well, as far as due dates and all that stuff like that.
I ain't gonna lie, I have test anxiety.
I understand, sir. I understand. So
I hate,
hopefully that'll alleviate some of that, because at least you have time to get your mind right,
yep.
and you don't have to worry about me saying, okay, everybody come on this day. It will be pretty much on your time and stuff. So I'll give you more details on that by next class, though.
Thank you, Professor Tucker.
Not a problem. Not a problem. So if you guys are good, I'm good. Um, have a great weekend. Be safe, and I will see you on Tuesday.
I'll see you too, Professor Tucker.
All right, man.
Professor
Have a
Tucker.
good one.
You too.